Okay, the first thing I want to discuss is a series. What is series? Well, a series is the summation, using a summation notation, from k equal 1 maybe, of the any sequence I want to call a sub k. A sub k represents the explicit formula for the sequence, no? And the upper limit is infinity. So actually, we have a1 plus a2 plus a3 and so on, no? Plus that, but it'll never finish because it's infinity. You have one final number here, 20, 100, so we stop. In this case, no, it continues forever. So the challenge is, this is a sum of the infinity number. Wow. Then there are two possibilities. Que the answer is infinity. Que according to the common sense, so you adding infinity number, for sure, the majority of the scenario give me infinity number, right? So infinity is no number, is a symbol to indicate a huge quantity, right? And when the situation happens, that means that the series diverge. Diverge. It's a technical name. Divergent. Technical verb que indicate que the value of this summation, increasing forever, blow up too much. However, there are another special, super special scenario in which you have a number. When it's a number, entonces converge. Okay, this is a a classical name in mathematics. In calculus 2, I promise that you are studying different tests to prove that one series diverges or converges. But in pre-calculus, we study specific example of the convergence. Let me try to bring one example, so one intuitive example in which I suppose that you understand what is the reason that you are in infinity numbers and it's converge. Okay, so I propose one idea. Look, I have the all real number line, not all real number, one segment. We have one segment. Okay, suppose this segment. It's enough. Okay, now this is 0. And this is 2. And this is 1. Let's suppose one summation like that. 1 plus 1/2 plus 1/4 plus 1/8 and so on. So you divide by 2. So next it would be 1/16, 1/32, and they never finish. Continue, tap, tap, tap. So 1 is this. The first guy, 1. Geometrically clear is 1. You add in the second, okay, 1/2 to 0.5. The answer so far is 1.5. 1.5. 1.5 is that segment. Next guy is 1/4. 1/4. And 1/4 plus 1/5. Remember, we're adding, no? We accumulate. 1.5 plus point and decimal. That guy is 0.5, no? And that guy is 0.25. And it's a 0.125. And so, you put in the calculator if you want. But enough. Now, suppose you adding now 1/8. Entonces es 1 more, so it's the half of the half. So it's this segment divided by 2, no? Entonces this is the other segment. Entonces es 1.75. 1.75 is this. And this is 1.75 plus 0.125. So 1.75 plus, I am doing calculator, 0.125. Then, the answer is, so including this, we have one more, get the half of this. So this point is 1.875. And so on. We continue this, addition this, gets the half of this. You continue this, gets the half of the half of this. So you understand that this series converges or no? The reason is because after that I adding a small number, a small, half. No, not necessarily happen. When you adding infinity small, converge. But in this particular example, yes, I want to prove mathematically. But the intuitive idea, suppose that I don't know equation, I don't know anything, using common sense, imagination. Do you understand que converge or no? Yes or no? Come on, I want to hear opinion. Yes. Change this. Of course, yes. Entonces, change. ¿A what value converge, in your opinion? ¿A what value converge? Converge when you adding infinity, guys. And what value converge? What is the final answer? What value? Infinity. No, entonces, si es infinity, es divergent. And my question was at the beginning, is converge or diverge? So we have two possibilities, divergent or converge. What do you think? What do you think? Converge or diverge? A ver. Converge. Okay. I agree with you. And my second question is, at what value converge? So you say que es infinity, entonces now this is a contradiction because infinity is divergent. So when you're adding infinity numbers, see the answer is infinity, for sure the behavior is divergent. See the answer is one number, I don't know, 20, 200, whatever, entonces converge. Entonces now when you say get the series converge, I agree 100% with you. My next question is, at what value converge? No idea? No idea? Come on, opinion, guys. David, Jonathan, Rebecca, Norris, Sydney. No idea? Daniel, Benjamin, no idea?
Converge.
Converge, right? You say que converge?
Yeah.
Okay, my next question is, at what value converge? Che, no idea? 2, es obvio. Es obvio que es 2. I intentionally, I represent geometrical. Es obvio que the answer is 2. So when you adding infinity numbers que have this behavior, que of course the next one is a half of the previous, the answer is 2. Ahora, wait, okay. This is intuition, no mathematical. Intuition is good in mathematics. Let me try to explain the idea behind this. So in the last class, we studied one formula. We studied one formula, que es the summation from K1 to infinity of the geometric sequence. Okay, the explicit formula of the geometric sequence is A1 times Rn minus 1. And let me try to call this a sub n. It's a formula. Well, the formula is a sub 1 parenthesis 1 minus r to the n power divided by 1 minus r. This is a formula. This formula, guy, allows us to compute no when it's infinity. Sorry, no infinity, no infinity. When there's m, when it's m. And n is maybe, I don't know, 500. Suppose you need to add in 500. No, 1 by 1, hello, no. N is 500, no. You're using that formula and you replace n for 500 and you copy the rest. A1 is the initial, the first element in the sequence, and r is the common ratio. Okay, it's a formula. I don't know. What is my problem now? My problem now is suppose series, and series is differently because it's infinity. Okay, and basically a sub m, well, is same formula, but under the consideration que m approach to infinity. Entonces we're using these tools, que es a calculus tools, que es a limit, but I don't want to explain the limit now. But remember, infinity is no number. Infinity is a symbol. A symbol can indicate a huge quantity, positive or negative. In this case, positive. Now, in order to understand a little bit, I split this common denominator A1 over 1 minus R minus A1, because you apply distributive property, no? Here and here, Rm divided by 1 minus R, and you try to investigate what happened if you approach it limit when the n approaches to infinity of this expression. Okay, it's A1, 1 minus R, minus A1, R to the n power, divided by 1 minus R. Now, this is obvious, que constant. This is constant. And non-dependent of n. So when you apply the limit, it doesn't change. The limit is just evaluate. Let me try to evaluate using my imagination. Because you don't know, you are not familiar with the limit. This is calculus 1. But it's 6, calculus 1. So now, let me focus in this part. R to the n limited when the n approaches to infinity. Suppose que R is a number bigger than 2, bigger than 1, sorry, bigger than 1. And suppose 2, to understand. You apply the limit of the 2 to the n. This is classical exponential. An exponential behave like that, look. This is exponential 2 to the n power. It's obvious que si x or m, in that case, is the name of our independent variable. It's infinity, so it's in this direction, too far. Now the exponential increasing too fast. This is increasing too fast, and this is totally divergent. However, there are another scenario in which the common ratio R is less than 1. Si it's less than 1, for example, limited, when the n approaches to infinity, suppose one hypothetical number to understand, 1 over 2 to the n power. By the way, it's exactly our initial motivation example. So the common ratio is 1/2. Well, okay, this is easy because you separate this 1 to the n and 2 to the n, no? The 1 to the n is always 1 and 2 to the n is 2 to the n. But you understand that this increases forever, and this is 1 over infinity, que is 0. Another way to visualize this fact, suppose the one exponential que contain negative exponent look like that, look. This is exponential, asymptotically. Sorry, it's asymptotic. Entonces, when the n approaches to infinity, the exponential 1/2 raised to the n power, es obvio que approach to 0. Okay, si approach to 0, that part is gone. It's 0. And stay alive in the formula only that part. So the summation m when the limit approach to infinity, let me call S, capital S is the summation of the series, S equal A1 divided by 1 minus R, que es that part. Okay, this is true? Yes, it's true under the consideration, o sea, when absolute value common ratio is less than 1. What is the reason I put absolute value? Because maybe it's positive or maybe it's negative, the behavior is the same. Okay? However, when it's less than, o sea, es obvio que converge. So we come back to understand much better this idea. We come back to our motivation example. Okay, remember, the a sub n in the sequence was 1/2 raised to the n power. Entonces, in this case, you expand a little bit, the first guy is 1. No, pero es, sorry. The first guy in the sequence is 1. n minus 1. Okay, remember the formula is this. A sub n is equal A1 R n minus 1. But in our example, A1 is 1 and common ratio is 1/2. Entonces es obvio que 1 is invisible and common ratio is R, entonces n minus 1. Let me double check it. Suppose n equals 0, no. Equal 1, sorry. For n equal 1, we have 1/2 raised to the 0 power. Oh, cool, it's 1. It's exactly the first value. For n equal 2, 2 minus 1 is 1, is 1/2 raised to the 1 power, it's just 1/2, and so on. N equal to 1/4, and so on. Okay, cool. Now, let me try to compute that formula. That formula is, well, the common ratio is 1/2, positive, and satisfy perfectly that condition. So I guarantee you in the test you put, no, professor, this series is convergent. At what value converges is the next question. Entonces, the formula is A1 divided by 1 minus R. In our specific example, who is A1? A1. What is our common ratio? 1/2. Now subtraction. 1 over 1 minus 1 is 1/2. Now reciprocal, the answer is 2. And we get this. And this is valid for any series. Because the most important thing you need to understand is, in pre-calculus, the only possibility that our series converges is, number 1, to be geometric. Suppose que es arithmetic, no converge. Suppose another crazy sequence, no, only geometric. In calculus 2, you study another, but in pre-calculus, geometric. And geometry is enough? No. Second condition, the common ratio less than 1. Yeah, you guarantee the answer. Directly you say convergent. But the third topic is our value convergent. Well, the formula is S equal A1 divided by 1 minus 1. End the story. You understand very well or no? Any question? No problema. Okay. In the test, you can see one question like that. Okay, it's given two series, and you need to predict if it's convergent or divergent, and also find the summation of the infinite element. But the only thing you should do, you see in the review package, okay, you prove que es geometry or no. No geometry, es divergent. Is geometric, then you find the common ratio. Si the common ratio is less than 1, you say yes. Our value and the formula. Okay, let's move on to the mathematical induction. It's the next topic. Mathematical induction. Okay, let me try to bring one motivation example in order to you understand what is the utilization of this technique. This is a fantastic method that we are using so far to prove formulas. Well, formula, inequality, whatever. Okay, suppose this example. Suppose at n equal 1, this is similar to the sequence, you know? You, for example, you take what happened? You take the odd numbers, just the odd numbers. Odd number is, I try to explain the problem, guys. 1, 3, 5, no? 7, and so on. And you take the odd number. For example, the first odd number is 1. And 1 is 1. And when you square, let's see what happens. Suppose that you take 1. And when you square, it's 1. And you take the two first, 1, 3, 1 plus 3. Well, 1 plus 3 is 4. Entonces now, this is n equal 1. Okay, this is a square, the 1. And this one represent, in my opinion, n equal 1. Now, this is n equal 2. And you see now, wow, look at that. 2 squared is 4. Wow, ¿es a coincidence or es a fact? Okay, no idea. Let me try the next. The next is 1 plus 3 plus 5, no? Okay, it's 9, no? This is for n equal 3. And you raise 3 squared and 9 again. Do you understand the idea? Let me try one more. 1 plus 3 plus 5 plus 7 is 16. This is n equal 4, and 4 squared is 16. My idea is I don't know exactly if we continue forever, because maybe this is good, this is good, this is good, this is good, but and when you try, for example, number 40 is bad. It's not satisfied the condition. This is the thing you try to explain mathematical induction. Of course, we finished this motivation example, but you understand the idea of the behind mathematical induction is you believe that something is good, something is, for example, how you translate this? When you adding 1 plus 3 plus 5 plus 7 plus pero no infinity, no, it's not series, it's a summation. Plus a sub m. What is the formula que generate? What is the explicit formula que generate 1, 3, 5, 7? Well, I suppose que es 2n minus 1. It's obvious, no? Because, for example, the formula a sub n equal to n generate the even number because you multiply by 2. So you're subtracting 1 or addition 1 is possible, could be. Entonces it's an odd number. When you adding what is the a sub n? Well, I copy like a 2n minus 1. Okay, like a 1 expression, no? And this is always n squared. 1 squared, 2 squared, 3 squared, 4 squared. I need to prove this mathematically. Mathematically, I need to prove this. Guy, do you understand or no? Answer me. Karim, Sebastian, Zoila, Jamie, yes. Shane said yes. Okay. Okay, this is the idea, Shane. This is the idea. How you prove that? Okay, cool. What is the idea? Okay, the mathematical induction method, the mathematical induction principle have two steps. Step one is called in any book the basic step. The basic step is very similar to the thinking we are doing. You try by 1, by 2, by 3, by 4. Entonces you believe que always is true. But you don't know si this true is valid forever. Okay, so this is the basic step. So normally, in the majority of the examples we're doing here, you try to prove the statement 1. The statement 1 is obvious when the n is equal to 1. See, this statement is true. Okay, you finish the basic step. Sometimes happen that the statement 1 is false. So do not satisfy my formula. But the statement 2 is true. And the statement 3 is true. So you predict that this continues forever. So not necessarily the first one is true. Depending on the example, but the majority of the example, yes. The majority of the example, at least I bring here in my course, yes, the statement 1 is true. So you prove it's false, I suppose que no. And the most important moment now is the inductive step. Inductive step. The two step, guys, only two. 1 and 2. What is the idea behind this? You assume that A sub k is true. And what is A sub k? Well, we have 1, 2, 3, 4, and the last guy is M. And suppose K is the intermediate value. Okay, maybe it's 20 or 21 or 19, but in general I call K. K is true. So you pick one guy, arbitrary. You assume this. If you want to prove under this assumption, S of K conditional A sub K plus 1 is true. So this thing together and the conclusion of these two logical statements is that A sub K1 plus 1 is also true forever. And this makes sense. And this is making sense because look. We have the domino piece, super domino piece. You put together like that, domino piece. Entonces now you hit that, and it fall, and hit the other. This is S1, it's true. It's true because fall. So hit the next one, okay? S2. And this is XK. And this is XK plus 1, maybe, no? And this is SK plus 2. And see, this is true. And my analog idea is this piece of domino rotate and hit the next one. Touch. Entonces this S2 is true. This change continue forever, but I don't know if it continue in one moment. No, but I assume that in one totally arbitrary in the middle, okay, I call K. This is true, 4, and hit the XK plus 1, and this process continue forever to infinity. This is the idea. It's very logical. It's best. Okay, actually, see, you express this idea not like a piece of domino, no? A mathematical statement. If you suppose that S1 is true, que is the base step, entonces now, so you prove somehow Okay, x1 imply x2 is true. That means que S2 is true, and the process continues here. Si S2 implies S3 is true, S3 is true, and this continues forever. But let's see one example to illustrate much better how you are doing this. I propose you, why not, take the motivation example at the beginning. So my motivation example I bring down here, but is proof using mathematical induction that 1 plus 3 plus 5 plus 7 plus 3 period plus 2n minus 1 is equal n squared. Okay. The professor explained me that you have two steps. The first one is basic. The regularly is at n equal 1. And n equal 1 means take the first one, the 1. The rest no. And in the right hand side is this. Igual a 1 squared. 1 squared is 1, entonces 1 equal 1. Super true. But not continue 2, 3, 4, 5 because no. You apply now the inductive step. Okay, you assume que S sub k is true. Now who is S sub k? Well, S sub k in our example is 1 plus 3 plus 5 plus 7 plus plus 2k minus 1 equal k squared. So that's easy. The only thing I did was replace n for k. But the convention que k is the intermediate value, no es the last one. Okay, now I try to using this information that's true, is my assumption, to prove what happened with the x k plus 1. No idea. So k plus 1 is easy because it's 1 plus 3 plus 5 plus 7 plus and you copy this plus 2k plus 2k minus 1 plus you include one more extra because it's the next, and the next is 2k plus 1 minus 1, like one new element. So the only thing I did was include one extra, que is the next, k plus 1. So I replace m, no for the regular case, it's k plus 1. It's the only thing I did. And in the right hand side, I do exactly the same. K plus 1 is squared. Everyone follow me so far? Yes or no? Okay. Now we almost finished. Now, that part, you are supposed que es k squared. Look, you assume this. This is k squared plus, now you apply here, why not? Distributive property, 2k plus 2 minus 1 should be equal, parenthesis, k plus 1 squared. And the rest is pretty easy algebra. So you have, for example, k squared plus 2k plus 1, no? Because 2 minus 1 is positive 1. If you want to FOIL this or factorization, either way, I prefer FOIL. You multiply k plus 1 times itself. Let's do it quickly. This is k squared. This is 1k. This is another k. And this is 1 times 1 gets 1. And when you add in that part, it's k squared plus 2k plus 1. And you see that these expressions are exactly the same of this. Now you prove by mathematical induction que this thing, que I suppose hypothetical at the beginning, que I am not sure it's true, actually it's true for any, for all n value belong to the natural. Do you understand the idea, guys? Yes or no? One more example, right? One more example, eh?
Yes, yes, please.
No, yes, please. Okay. Okay, one more example, classical example. Look, the example that you accept next class, the property. The property you see the formula, guys. Example 2 is the classical formula that we using next time. 1 plus 2 plus 3 plus bam 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 plus m, get the summation of the first m value of the natural number. The formula is m plus 1 divided by 2. Do you remember that formula or no? You remember, right? We use it in several examples, no? You remember? Remember the story of the elementary school? Laplace genius discovered que suppose que es 1 plus 2 plus 3 plus 100. The answer was 100 times 101 divided by 2, no? Actually, we have 50 couple. 100 divided by 2 is 50. Multiplication by 101, que es 5,050. Do you remember that formula, right? All right? Yes. However, I never prove that formula. You have said, okay, I obey, professor. Let me try to use a mathematical induction to prove that this formula is true. And another formula is possible doing that. Look, remember, 2 steps. Base step. The base step is S1. And X1 is using the first one, que 1. 1, you take the first in the left hand side. In the right hand side, you evaluate n equal 1. Entonces 1, paréntesis, 1 plus 1 divided by 2. 1 plus 1 is 2. 2 times 1 is 2, divided by 2 is 1. 1 equal 1 is 2. Okay? Now, inductive. Inductive is easy. You suppose que S to K is true. Now, who is S to K? It's the same formula, but now you not using n anymore because I suppose K is the last one. You put intermediate value K. S equal K plus 1 divided by 2. I copy the same, but using K, no N. Okay? Y I suppose que this statement is true so far. Suppose que K is, 1,000. So the first 1,000 number is true. Pero I cannot prove for infinity value. No. Entonces now I investigate what happened with the SK plus 1. SK plus 1 is easy. You copy 1 plus 2 plus 3 plus plus K, and you include the next K plus 1. At least in the left hand side, you include one more K plus 1. Cool. In the right hand side, well, it's more complicated because you replace K for K plus 1. So actually, we have K plus 1 times K plus 2, no? Make sense, no? You plug in here K plus 1, and here K plus 2, K plus 1, sorry, and 1 plus 1 is 2, divided by 2. Do you understand this idea? Good afternoon. So this is one email of the another students. Okay, however, you accept, you suppose, you assume, assumption, que this expression, que by the way is this expression, que by the way is this expression, is equal K k plus 1 divided by 2 plus k plus 1 is equal this k. Not necessarily I copy that. Okay, you want copy, you can copy. K plus 1, k plus 2 divided by 2. And the rest is just algebra, baby algebra. You apply algebra, that's it. For example, I propose you in the left hand side, you factorization. Factorization, no. You apply the least common denominator, get 2. And we have k parenthesis k plus 1 plus 2 times k plus 1. You follow me? Yeah, I can see clear. Wow, k plus 1 is common factor, factor out. And open new parenthesis, inside we have k. This k is this k plus 2 divided by 2. And you see this expression is equal to this. Now I prove by mathematical induction. Super clear? More clear, no? Because I promise in the review packet we are doing one more example. One more, not too much. And it is only one problem of the mathematical induction, different. Any question, guy? Don't try to find complicated because it's not too complicated. It's easy. No, there are problems that is too hard, but no. I never put hard problem in the mathematical induction. Everything okay? So now let's move on to the last topic. This is the last, I promise. The last topic is the binomial theorem. Binomial theorem. It's very interesting. Okay, this theorem was discovered by Newton when the Newton had was 21 years old. What is the idea behind binomial theorem? Okay, it's easy. Look, suppose we have a binomial, a plus b, and you raise to the 0 power, and you have a plus b, and you raise to the 1 power, and you have a plus b, and you raise to the 2nd power. If I want to investigate the formula, what is the general formula to obtain everything to the 3, 4, 5, 6, 7? This is the idea. It's obvious that a plus b to the 0 power is 1, because any expression or number raised to the 0 power is 1. By the way, this one I want to copy here, because maybe it's useful to explain the formula. And a plus 1, a plus b, sorry, to the 1st power is a plus b. Entonces now I saw que coefficient here is 1 and coefficient here is 1. Therefore, I copy this one. One. By the way, this was by n0. That was by n1. And a plus b squared is a squared plus 2 times ab plus b squared. Entonces the coefficient in this power 2 es 1, es 2 y es 1. Entonces I copy. 1, 2, and 1. This is for n2. Let me try another. A plus b cubic. Well, this is too long. I'm doing by hand is crazy. No, not crazy. Actually, not crazy. This is 3 is acceptable. But as 4, 5, 6 is long. But I present it's easy to compute it, but it's long. Basically, you apply 43 times. It's okay. It's a cubic plus 3a squared b plus 3ab squared plus b cubic. Oh, entonces I saw a partner the regularly, but I copy the number, guys. I copy the number que es 1, 3, 3, and 1. Look, this coefficient is this 1, invisible, this 3, and this 1, invisible, right? You follow me? Yes or no? This was the number coefficient for N3. Let's do one more. Yeah, immediately I discovered the partner. Look, a plus b to the 4th power. Binomial theorem we are studying. It's a4 plus 4 times a to the 3rd power, b plus 6 times a squared b squared plus 4 times ab cubic plus b4. Let me copy it right. In that case, the coefficients would be 1, 4, 6, 4, and 1. This is for m equal 4. And we continue. Of course, no, not necessarily continue because I discovered something. I discovered that we have that triangle. That triangle, guy, is Pascal. Triangle. And what is the relationship between the number and Pascal triangle? Look, suppose this 6 come from 3 plus 3. For example, these 3 come from 1 plus 2. So in the previous row, you're adding the number and you obtain this. Entonces no necessarily are doing the stupid FOIL, it's too long and it's consuming time. For example, to the 5th power, because I know that in the Pascal triangle for n equal 5 would be 1, 5, welcome from 5, 1 plus 4, 10, welcome from 10, 4 plus 6, 6 plus 4 is 10 again, and 4 plus 1 is 5, and 1 is the last case. Notice, in the Pascal triangle, that part is always 1, and the number in the middle is no 1, is obtaining by the summation, the 2 in the previous row, the 2 adjacent numbers. Notice, this is the first thing. Another important, because I want to form it. I have some idea how it look like the formula of the Newton. Entonces now I notice that, for example, A and B start in the same power. It's a 4, 4, 3, 3, 2, 2, 1, 1. Entonces it's obvious that the first guy is A to the 5th, and the last is B to the 5th. Is it clear, right? Now, the next after the A to the 5th power plus is 5, no? The coefficient is 5, and you have A and B, but the power of the A is decreasing by 1, it's 4 power, and the power of B is increasing plus 1. With the previous, no, actually we have no B here, is because I suppose it's B0. 0 plus 1 is B1. Actually, this is invisible B, but this is B to the 1. What is the next in the 5th power? Well, it's 10. It's 10. It's A to the 3rd power, because it's 4 minus 1, and B to the 2nd power, because it's 1 plus 1. the exponent for the A is decreasing, plus 1, and the exponent for the B is increasing, plus 1. What is the next? It's 10 again, no? 10 A squared, B cubic, decreasing and increasing, plus 5 A cubic, B4, plus B5. Okay? So far, do you understand? Oh no. A ver, opinion. David, Jonathan, Rebecca, Gustavo, Sidney, Shane, que you always understand everything. Clear? Okay, cool. I don't know. What's the merit for the Newton? Well, Newton now, Newton condensing this in one formula. Newton say, bam. What is the formula? A plus B to the n power. Well, it's too long. Actually, I don't know exactly what it's saying. It's 40, it's 500. But you are using summation notation. And in the formula of Newton, I put the index variable K, maybe K from 0. We start in 0. Look, it's possible 0 to the m. Entonces we condensing. I don't know. Suppose que n is 40. Hypothetical example. Entonces the summation contains 41 terms. One and one more. Look at that. To the fifth power, we have 1, 2, 3, 4, and 5. And 6. Sorry, 6. Okay, I make a mistake. Look, is 1, 2, 3, 4, 5, and 6. Now we have one more. So when you expand the binomial theorem, we have one more. Suppose in 4, we have 1, 2, 3, 4, and 5. One more. To the one coefficient, que no idea. Well, like, yes, I have idea, but using the Pascal. The Pascal is good when the number is not too big. But 40 is crazy, the Pascal. So I need to discover that formula. But it's okay. It's easy. And A sub n minus K and bk. Remember, in this example, in the last one, n is 5. Entonces, the first coefficient is 5 minus 1, que 4. Look at that. This 4 is this, n minus k. And this coefficient is 1 because k is 1. So k0 is this element, k1 is this element, k2 is this element, or this monomial, k3, k4, and k5. Wait. 0, 1, k5. Entonces es obvio que in between 0 and 5 we have 6 monomial, 6 terms. And this is the formula. Okay, so what is the thing fly in the air? What is this number? Well, this number we can use a combinatory number. It's similar to the combinatory number that we use in probability and statistic. A combinatory number que we can represent like that. Combinatory number NK. Combinatory number represent in statistics and probability. In combinatory theory is how many elements we can form using M element taking a K. Suppose 3, 2. What means that? You have 3 elements, 1, 2, 3, and you need to form how many combination you can form taking this element 2 by 2. Of course, no consider repetition. No, because repetition is variation, and this is no variation, it's combination. Okay, too much, blah. What is the formula, guys? The formula is The formula is n factorial divided by k factorial multiplied by n minus k factorial. This is the formula for the combination. This formula is represent like a combinatory number, and this is a combinatory symbolic way, no? Nk. Bang! And this is the Newton formula. Okay, let's practice. Let's practice Newton. I bring some example. If you want, by reduce the time, let's do exactly the example in the review package. Okay? Review package have in the binomial theorem have 3 examples: 17, 19, 17, 18, 19, and 20. That's it. Look, let me show you. It's super easy. Super easy. No big deal. Look. Okay, I want to erase everything. Okay, look. This is the question 17 in the review package. 17 is expand 2x plus 3 to the 5th power. Okay, to the 5th power. Entonces you say, bueno, professor, but you explain using A and B. Okay, no problem. I suppose in this scenario, A is 2x and B is 3, right? No problem. It's the same formula, but okay. So now, when you expand, you copy combinatory number 5, 1. No idea what is that. We are using the factorial, maybe we're using backend. And you copy A, que es 2x, raised to the 4th power. Welcome from 4 is 5 minus 1. And B is 3. 3 to the 1 power. I put explicit like this. You know very well that power 1 is invisible. Okay, you understand. This is my first. Remember, we have 6 terms because the power is 5. What is the next guy? The next guy is 5, 2. Because this was for K1, K0, sorry. No, I make a mistake. This is K1, K0, no, it's not like that. It's 5, 0. No, mistake, totally mistake. Look, K0 is combinatory number 5, 0. No 1, hello. And this is A, gets 2x raised to the 5th power. Because it's A minus K, K is 0. And 3 times 0. Okay, this is nothing. This is 3 to the 0, 1. Plus. But you don't need to do. I want to do step by step because I want you understand it. Welcome from this. But no, you omit this 3 to the 0, 1, entonces it's invisible. What is the next? The next is combinatory number 5, 1, 2x to the 4th power, and 3 to the 1 power. This is for k equal 1. Plus combinatory number 5, 2, 2x to the 3rd power because you're subtracting 2, so 5 minus 2, and 3 to the 2nd power. This is k equal 2. I want to continue not here, so not here. Because I know that we have k3, the 2, sorry. We have k4 and 5. Entonces, combinatory number 5, 3, 2x squared. One easy way to see that is you decreasing the exponent 5, 4, 3, 2, and you increasing the other, gets 3 to the 3rd power. And this is for K3. For K4 plus a combinatory number 5, 4 is 2x to the 1 Because of 5 minus 4 gets 1. And 3 to the 4 power because the k is 4. Plus the last, I suppose, que es 5, 5. 2x raised to the 0. It's obvious. There's 5 minus 5. And 3 to the 5. This is from k5. Okay, we're feeling no. So let me try to explain the combinatorial number gets not clear so far. We can use it when it's a small value 5. We can use a Pascal. We can 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, and 1. This last row is for k equal 5. No? The coefficient is 1. So this guy, let me use a different color. Is 1. This is this. This is 5. Is this. This is 10. This is also 10. Wow, weird, right? This is 10. This is 5. And this is 1. Let me prove any. Suppose this 10. Or this 10. Suppose que no Pascal. Suppose que es higher power. Suppose 40. But no. Let's use this. Look. Suppose I want to compute by hand or calculator, either way. Combinatorial number 5 2. I don't remember very well the Pascal. So f 5 factorial divided by 2 factorial and 5 minus 2 factorial. Ese formula. Entonces, obviously, es 5 factorial divided by 2 factorial. Que, by the way, 2 factorial. Do you remember factorial, guys? So 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. And so on. 2 factorial is obvious que es 2. Es obvious que es 2. And 5 minus 2 is 3. And 3 factorial, let me leave it like that. 3 factorial. And you split or separate, expand 5 factorial like a 5 times 4 times 3 factorial. Then you expand until you have the factorial similar to the big factorial in the denominator, and this cancels out. So 5 times 4 is 20, and 20 divided by 2 is 10. The majority of calculator in the probability part have combinatory theory, so combinatory operation. We need combinatory numbers. Let me prove another. Suppose 5 3. 5 3. 5 3 is 5 factorial again, over 3 factorial, and 5 minus 3 factorial. Okay, so now 5 factorial in the top, and the bottom we have 3 factorial, leave it like that, and this is 5 minus 3 is 2 factorial, but 2 factorial is 2, because 2 times 1. So 5 factorial is 5 times 4 times 3 factorial. You expand until you get the same higher factorial in the bottom. The answer is the same, 20 divided by 2. And it's not coincidental, it's a fact. Okay, this is symmetric, the Pascal triangle is symmetric, so that number and that number is the same. 1 5 10 10 5 1. 1 4 6 in the middle, 4 1. Okay, I feel it. No, of course no. This is explanation, the coefficient, whatever. So what is the answer? What is the answer? What is the answer? What is the answer? Look, the answer is look. Okay. Okay. This is the thing. This is 1, sorry. And 1 is invisible. And this is 2 to the 5th power, que es 32. X to the 5th power. And 3 to the 0 is 1. Cool. This is my first element. 32 x to the 5th power. Plus something. This is 5. So the combinatorial number 5, 1 is 5. And 2 to the 4 is 16 times 3. And when you put together, you multiply 5 times 16 is 80, I guess so, times 3 is 240. 240 what? 240 x to the 4th power. Okay, this guy. Plus 10, the 2 cubed is 8, and 3 squared is 9, and multiplication, 8 times 9 is 72, and 10 is 720. X to the cubed power, plus, now here we have 10, we have 4, and we have 27, no? The 3 to the cubed power is 27, and when you multiply each other, is 1080. 1080 who? X squared. Is this x to the 2nd power? No? It's the only variable that we have. Plus, likewise, this is 5, this is 2, this is 10, and 3 to the 4th power is 81. So actually is 810x plus, this is 1, this is 1, this is 3 to the 5th power is 243. Bang! And this is the answer of 2x plus 3 to the 5th power. Do you understand very well? Binomial theorem, guys. Binomial theorem. Question. Guys, this is just the beginning. If you need to take calculus 1, calculus 1 is hard, but calculus 2 is exponential hard. Okay, and any majors, engineer, medicine, you need to take calculus 1, 2, and engineer and another science, mathematics, of course, and physics need to take calculus 3 also. Okay, this is nothing. This is trivial. This is kindergarten. Do you understand or no? Too quiet. Okay. Let me try continue the review. This was 17 question review. This is the answer. 18 now. 18 is Caesar. What is the complication in 18? Well, the complication, 2 complications. Number 1 complication is to the 6th power. So it's W minus S to the 6th power. I never see 6th power in the Pascal triangle, but I try. And another complication is minus. And you prove the formula, professor, for A plus B. Maybe I can do to the 6th power, but plus, no minus. But okay, to say now, you suppose que A is W, but B is minus S. So any turn, you replace B by minus S, mentally, of course. So now is combinatory number 60, W to the 6 minus 0. Not necessary to write that. And X or minus X to the 0. Not necessary to write like that. Because of 1. Plus combinatory number 61, W5 minus X to the 1. Plus combinatory number 62, W4, and minus X to the 2nd power. Let's do one more in this line. Plus combinatory number 63, W3, and minus x cubed. Because you see that the exponent of the w is decreasing and the exponent for the minus s is increasing. No? What is the next? The next is combinatory number 64 w2 minus x 4 power. Notice that when you add in the exponent 5 plus 1, 4 plus 2, 3 plus 3, the answer is always 6. Que es the initial exponent we have in the binomial, 6. This is a fact. Okay, and 2 plus 4 again 5. Now what's the next? The next is a combinatory number 65. W1 gets invisible. Minus x to the 5th power. And the last one is 6. And we end it with the same number. W0, pero W0 es 1, entonces no es necesario to write. Minus s to the 6th power. Okay. No idea of the coefficients. Okay, again, if you prefer Pascal, okay, Pascal is easy when you have not too much values. Is 1, 1, 2, 1, 1, 3, 3, 1, for N3, for N4 is 4, 6, 4, 1, N5 is 1, 5, 10, 10, 5, 1, and N6, that's my problem now, is 1, 6, 15, 20, 15, 6, and 1. So this number always says 1. Get this. 1. This number is 6. This number is 15. This number is 20. If you want, I can do that using the formula at least 1 to verify. And this is 15 again. And this is 6. And this is 1. Notice that when this N0 is 1. And when this NN is also 1. Look, 6, 6, 5, 5, whatever. This is easy. Now, however, what happened with the negative? Well, the negative is easier because when the exponent is even, it's positive. But when the exponent is odd, it's negative. So actually, we have W6 minus 6 times, this 6 is this 6, W5 and S to the 1 power. And this minus, case this minus, I put in the front. Plus 15, W4, X squared, and positive. Because the exponent is even, and you know very well, when it's negative and the even exponent is positive. The answer. Plus 20, or minus 20, sorry, W3, X cubic, plus 15, W squared, X to the 4th power positive. It's alternating, 1 negative, 1 positive, 1 positive, 1 negative, alternating. Minus 6, W X to the 5th power, plus, now the next is plus X to the 6th. And this is the expansion of the W minus X to the 6th. 1, 2, 3, 4, 5, 6, and 7. This idea is clear. You need to know that to understand calculus. Okay. So now, in the 19 problem, no necessary expand everything. No. We need one more specific. For example, it's given. Look, question 19. 9. Look, it's given 1, 9. It's given one binomial, okay, 9x plus 6 cubic. Okay, nice. It's not too long. I want can you find the coefficients for the term, coefficients of x. So I suppose that when you are doing the expansion, one by one, bam, 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 bam. Okay, by the way, si es 3, we have 4, no? 1, 2, 3, and 4. No, not too much. You want specifically the term que contain only one x. X to the 1 power. Es the idea. Es the idea. Es the idea. Es the idea, I suppose. Ajá, entonces now, I know very well que A es 9x and B is 6. Now, the formula say, Newton formula say que 9x plus 6 to the cubic power is the summation from k0 to 3. So in between 0 and 3 we have 4 elements of the combinatory number 3k, because 3 is a constant, it's the exponent, the original exponent, and k no, k is 0, 1, 2, 3, and that's it. And A, in our example, is 9x raised to the m, pero n is 3 minus k. Multiplication by b, que b is 6 raised to the k. Okay, I apply specifically in our example the Newton formula. And the goal is find the coefficients. Okay. Pero the restriction in the problem is que I need que the exponent of x would be 1, o sea, x to the 1 power. Bueno, entonces I understand que actually in the formula the exponent is 3 minus k would be 1. Therefore, es obvio que k es 2, because 3 minus 2 is 1, pero no, que I'm using algebra 3 minus 1 is k es 2. Okay, entonces es basically is the third. So we have k0, k1, k2 is this one, and k3, 4 in total. Okay. Entonces, actually, I know very well que k is 2. So in the formula I copy combinatory number 3 to 9x to the 1 power, because 3 minus k is 1, and this is invisible, and 6 squared, because k is 2. Combinatory number 32 is, I don't remember, I use in the Pascal, or the formula 1, 1, 2, 1, 1, 3, 3, 1. It's n1, n0, sorry, n1, sorry, n2, this is 1, this is 2, and this is 3. And the coefficients are 1, 3, 3, 1. Specifically is that 3, because it's in the third position. But just in case, if I'm not sure, no problem. I try to use the formula. The formula say combinatory number nk is equal to n factorial divided by k factorial n minus k factorial. In our specific example, I need to find 3, 2. That's 3 factorial divided by 2 factorial and 3 minus 2 factorial. I compute the first denominator. 2 factorial is 2. And 3 minus 2 is 1. 1 factorial is 1. And 3 factorial is 3 times 2 times 1. So because 2 and 1 is cancelled, the answer is 3. But this is 3 times 9x times 36. 6 squared 36. And you multiply each other, the answer is 972x. So you ask the question say, the coefficient of x in the expansion of this binomial The answer is 972, que es the coefficients. Because this clue, que es x to the 1, indicate the position inside the binomial form. Okay? By curiosity, just curiosity. So you expand, suppose that you don't know, you don't understand very well this, no problema. You expand everything using the 4. Yeah, I did that, but in order to save time, I put the answer. The first answer is 729 x cubic plus 1458 x squared plus 972x plus 260. This is equal 9x plus 6 cubic. And by the way, this is the guy that we are looking for. Look. Clear or confusing? What happened today, guy? Oh, somebody changed. I don't like this. Clear, Gustavo Garcia. Okay, one more, Gustavo. One more. Suppose 20 in the review. 20. 20 say. Find the 9, wow, term in the expansion of x plus 3y raised to the 10 power. Wow. Okay, no problema. I know que n es 10. I know que A es x. Y I know que B es 3y. Newton formula. Summation from n0 to k0, sorry, no, n, k0. K is the index variable of the summation. 0, 1, 2, 3, 4, 5. N is the top, the upper limit, upper bound. And this is combinatory number nk, a to the n minus k times bk. In our specific example, actually we have 11. So we have, look, let me show you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 11 term because it's 10. One more. This is for K0. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If you want to discover the 9th term is in the 9th position, no? As you see position, this is 1 position, 2 position, 3 position, 4 position, 5, 6, 7, 8, 9, 10, and 11, right? So in the 9th position, es obvio, 9th position, es obvio, 9th position, es obvio que K is 8. Wow, es, you don't need to do this stupid box que I did now. No, you realize, see the position is 9, K is 8. Why? Because K count from 0. The 0 is the first position. The detail, the sophisticated detail, is to understand that the position is given in the question is 9, corresponding with the K8. Okay? So basically, I need not the summation. So I delete the summation. No. I focus it into compute expression here in that position. Okay, 9 position, is K equal 8. That's a combinatory number 10, 8, because n is 10, no? You know, at the beginning. And A is x. raised to the, I don't know, 10 minus 8. This is 10. This is 8. Que es 2. The power 2. The power 2. And B is 3y. 3y raised to the 8 power. Okay. We almost finished. Now. Compute the combinatory number. Combinatory number 10 8 is 10 factorial divided by 8 factorial, 10 minus 8 factorial. This is too long doing the Pascal triangle. No. You compare the denominator part, 8 factorial, and this is 2 factorial, no? And 2 factorial is just 2. Just 2 times 1. And 10 factorial you expand is 10 times 9 times 8 factorial. And cancel out 8 factorial and 8 factorial, and 10 times 9 is 90 divided by 245. At least I know que this coefficient is 45. So this guy is 45. X squared times something to the 3 to the 8 power. I put in my calculator. 3 power 8. Wow, is 6,561. Y to the 8 power. And finally, you multiply 6,561 times 45. And the answer is 26. 26. Now, I make a mistake. Okay. Yeah. I make a mistake, of course. It's 6,561 times 45. 45. I forgot 5. Okay, there you go. It's 29,000. No, 295,245. And the variable is x squared and y8. It is my final answer. This is the expression of the term is located in the 8th place, in which k is 8. Cool? You follow me? So we did now the question and the review package with question 17, 18, 19, and 20. Okay, the question somehow relating for the binomial theorem. Okay, 2 questions, totally expansion, completed, not too long, of course, and some specific value, a specific term in one specific position is given explicitly or no, because sometimes it's explicit when they indicate the position 9, 10, 11, or no, indicate the exponent. Suppose I need x to the 7 power or y to the 8 power. So now somehow indirectly indicate the position. Cool? Entonces now in the rest of the time, que es 10 minutes, we are doing at least one question in the review, one more. The question 1. I start in the correct order. Question 1. Number 1. Number 1 is say 25 x squared plus y squared minus 350 x plus 1000 or 1200 equal to 0. So now you need to identify this conic section. Identification, what's the name? Remember, we have different is ellipse, a parabola, or a hyperbola. After that, we classification horizontal, vertical, and we determine according to this the parameter, no? A, B, P, whatever, HK, using the algebra. What do you think? Look at this. Is ellipse, parabola, or hyperbola? Opinion. I need to hear opinions. Nobody know anything? Wow. And you expect to get good grade in this test? This test is easy. The complicated passing. In my opinion, the complicated is number 3. Maybe no, it's up to you. It depends on the student. I understand very well the matrix, professor, but I don't understand the conic section. I don't understand. You have to take calculus. What is the criteria that we are using to classify the conic section? Sydney? Shane? You don't remember or you remember? No idea? I need to explain again one more time.
I'm good, Professor.
Bueno, I know that you are good, but you answer my question or no?
Me or the other?
Say again?
Me or the other?
My question was, this equation that is right in the whiteboard corresponding with the ellipse, parabola, or hyperbola? No idea?
No, sir.
Okay. I repeat again. Look, it's amazing. Look, normally when you have x squared and y squared and plus in between them is ellipse. When you have x squared and y no square, or x no square and y square, two situations is parabola. When you have x squared minus y squared or y squared minus x squared, a hyperbola. Do you remember that?
Yes.
For sure, it's ellipse, no? Because it's a plus. Look, you see the element important is x squared and y squared. And where's the operation between them? Plus, addition. To say it's ellipse. Okay. Here. Okay. It's ellipse. Classification ellipse. Wow. Now, this equation, unfortunately, is expressed in general form, non-standard. Standard nice. In standard, you see what is K, what is H, what is A, what is B. In this case, no, I don't see anything. But it's easy. Look, you copy 25x squared. That you grouping the x part minus 350x. This and this is the same variable x put together. And y no, I put separately. And why no? 1200 I put in the other side. And now I need to apply some algebra here in order to express a standard. And the algebra is easy because you factorizations are the greater common factor. The greater common factor between 25 and 350 is 25. 25 is a great common factor. So you copy 25, you factor out 25 outside, and you have x squared minus something, and this something is 350 divided by 25, get 14. Plus, now I put artificially one number here that completed the square. Plus y squared equal minus 1200 plus another box in order to keep the equilibrium of my original equation. Do you follow me? A ver? Yes. Now, Gustavo, you take 14 without sign. I don't care the sign. You divide by 2 and square. This is the formula, b over 2 square. This is the completed square. 14 divided by 2 is 7, and 7 squared is 49. So you put 25 x squared minus 14x plus 49 is the answer when you divide by 2 and square plus y squared. In order to doesn't affect my equation, you include in the right hand side the multiplication 49 here, 49 times 25. Okay, the multiplication of that number and that number. Actually, you introduce artificially 49 because we need to complete the square. However, when you put inside the parentheses 49, actually you put totally the multiplication 49 times 25, que is 1,225. Okay. Almost I finished the conversion to a standard. I know that this is perfect square trinomial, and the answer is x minus 7 squared plus y squared equal 25, because this minus this is 25. And remember, in a standard, right hand side must be 1. So you divide by 25 here, 25 here, 25 here. My equation nice and totally standard form is x minus 7 squared. 25 divided by 25 is 1, invisible 1, plus y squared over 25 equal. Wow, amazing. And this is the equation of the ellipse in standard. And now you see clear who is H, who is K, who is A, and who is B. Who is H and who is K? Who help me?
Repeat that.
Say again.
No,
Who is H? Remember, compare the equation. The equation is the standard equation that you need to remember is x minus h squared over, I don't know si es a squared or b squared, depende si es horizontal ellipse or vertical ellipse, plus y minus k squared over a squared or b squared. No, I don't know, depending on this example, equal 1. Who is h? Clear, you see. 7. Negative 7 or positive 7?
Negative.
No, you are wrong. Positive. Remember, the formula have a minus. When you see positive, it's because the value of h is 7. Right?
Right.
What about k?
25.
No. We have nothing. No. We have nothing inside. So what number you have inside the variable? Now, minus something. Minus 0. Do you see or no?
Yes.
So k is 0. My challenge is who is A and who is B? Who is A squared, for example, and who is B squared?
A squared would be L.
What is that? A squared is?
That's
25 or 1? We have two factors here.
1.
No, A is always the bigger. So you have two numbers, 25 and 1. And A is the bigger and the ellipse. This is the major axis. Or like that, I don't know exactly. This is 25. How do you know? You select the bigger number, the greater number, and this is 1. Therefore, A5.
A would always be the greater number then.
Say again?
A would always be the greater number?
Absolutely. A is the greater. You have two numbers. Suppose 3 and 4. What is A? 4. And the ellipse. The ellipse is the geometric place que look like a circle, but not exactly circle. It's a closed figure, But we have one major axis, and this is the minor axis. And the major is A, and the minor is B. So you need to know that A is the big number. Okay, so with this information, everything is clear, at least for me. Look, it's a my rectangular coordinate system because the goal, the final goal is doing the graphic. XY, the center of this ellipse is located at the point 0, 7,0, sorry, 7,0. So H center is H, K. In our specific example is 7,0. This is the same. 1, 2, 3, 4, 5, 6, 7. 7,0. Okay, guys, I propose you, the time is over. I propose you continue next time, okay? So on Monday, it's the last day. We continue the review. Okay. Okay, please try to start doing the homework. We have 3 homework waiting for you and 1 test waiting for you. And it's due July 26. Okay. Okay. Bye-bye, guys.